Okay, read the question. There are two parts to this. During lightning flashes, nitrogen combines with oxygen in the atmosphere to form nitrogen monoxide. Okay, and no. So in the first part, the output is NO. Okay, how NO is formed? Nitrogen combines with oxygen, right? So nitrogen combines with oxygen. So nitrogen molecule is N2, combines with oxygen molecule N2. I just looked up and found out what is the molecular formula of oxygen. Okay, that's how I found it, and nitrogen as well. So to balance this equation, all right, 2 and 2. And 2 plus O2 is 2 and 2. That is equation number 1. Okay, now the second part, again, NO further reacts with O2, right, and produce nitrogen dioxide, NO2. So to balance this equation, it's 2 oxygen here, 2 oxygen. Well, there's 3 oxygen on the left hand side, so let me make it 2. So there's 4 oxygen. So if I make it this 2, there's 2 and 2 in here. 2 plus 2, 4 oxygen here. Okay, good, very good. Let me erase that. So now you got a second equation. So question number 1. What mass of NO2 is formed when NO reacts with 384 grams of oxygen? So it is given that they want us to use 384 grams of oxygen. So how much of NO is required and how much of NO2 is produced? That's the question, right? So in this equation, we have these moles, okay? 2 moles of NO and 1 mole of O2 and 2 moles of NO2. We don't write this equation in terms of grams, okay, in terms of mass, okay? But it is given that 384 grams of oxygen is what we are given, okay, for this experiment. So how do you convert that into moles, you know? How many moles is 384 grams is equivalent to? So to calculate that, let's find out how much O2 is weigh. What is the mass of O2, right? What is the mass of 1 mole of O2? By looking at the periodic table, we know that the mass of O2, O is 16. Okay, 16 is the 16 atomic mass unit is how much 1 atom of oxygen weighs, right? So 2 atoms of oxygen weighs 2 times that, which is 32, right? 32. Okay, so what that means is, 1 mole of O2 weighs 32 grams, okay? 1 molecule of O2 weighs 32 atomic mass unit, but 1 mole of O2 weighs 32 grams, okay? That's very important. 1 mole of O2 weighs 32 grams. We need to keep that in mind for the purpose of calculating the mass of 2 moles of NO and 2 moles of NO2. Okay, so now we got the mass of 1 mole of O2. Okay, so now we can find out, 384 grams of oxygen is what we have. Okay, so how many moles is equivalent to 384 grams, or 384 grams is equivalent to so many moles? So how do you find out that? 384 grams of O2, meaning, or that is equivalent to certain number of moles. Okay, we know that O2, 1 mole of O2 weighs 32 grams. So how do you convert 384 grams into moles? 384 divided by 32, right? Correct? Let me use a calculator. I probably don't need a calculator, but let me use a calculator anyway, so you can watch what I'm doing. 384 divided by 32 is 12. Is 12. Okay. So what that means is 384 grams is equal to 12 moles. So in this equation, right, we don't write grams, we write moles. So again, they want us to use 384 grams of O2. What that grams means in terms of moles, that is what we just calculated. We calculated that by finding the mass of O2, 1 mole of O2. So 1 mole of O2 weighs 32 grams. So 384 grams of O2 contains 12 mole. Okay, so let's write that equation down. So we have 12 moles of O2, not 1. So initially it was 1 mole, right? And now it's 12 mole, meaning it's 12 times, right? 12 times. So this also has to be 12 times 2NO, right? Because this, initially it was 2. Now it has to be 12 times 2. Okay? 12 times 2. Similarly, in the output, 12 times 2NO2. Okay? So now we got a new equation. Let me simplify this further. 12 times 2 is 24NO plus 12O2 yields, again 12 times 2 is 24NO2. So we got a new equation here, and this is what they want us to calculate. So in other words, they want us to use 384 grams of 384 grams of oxygen, O2. Okay, so the corresponding amount of